Thank you. Hi, my name is Brian Spencer. I work for Qualcomm Connect Experience as one of the premier and founding members of the AllSeen Alliance. If you bear with me one second, I'm actually having a little trouble sharing the display here. I don't know what just happened. Okay. I don't know what you guys can see on your screen here, but I'm having a couple little technical difficulties. Let me get out of this. So today we're going to focus on covering the AllJoyn Software Framework, which is the piece of software that is powering the AllSeen Alliance. And I'm going to go over the overall architecture, dive into some of the new features and the new SDK that just rolled out, the 14.06 SDK, as well as talk about a new piece of software. I know in the description we made mention about discussing C++, but due to a recent change, we were able to get some software out rolled on leading up into the hack. So I'm going to do this a little bit different here. Okay, hopefully everyone can see my desktop.
Looks good, Brian.
All right, sorry about that technical difficulty. So the AllJoyn Framework, it's an open source piece of software hosted by the Linux Foundation, run by the AllSeen Alliance. And what it allows for is the ability for developers like yourselves to use AllJoyn to publish APIs across a network, local, in proximity. So this isn't going out to the cloud. This is about talking to other devices and really AllJoyn entities, AllJoyn applications that are on the same network. The reason that it's nice to use and publish APIs instead of a byte protocol or some other type of means to connect and exchange information is because we work with APIs. Really, when you use AllJoyn and you dial up a remote entity, you're in essence loading a library almost. So AllJoyn at its core is a distributed bus architecture. The formation is ad hoc, meaning as you go about, you can find different AllJoyn applications, you can connect, and you can go ahead and start to invoke those methods on the applications that use the SDK. And the AllJoyn framework is protocol independent. So it can run over Wi-Fi, Wi-Fi Direct, Ethernet, PLC, so power line communication, Bluetooth, and it can also run over other transports. So as a software, it's written in an abstract way to support the ever-growing Internet of Things. So at a high level, there are a couple of concepts that I'm going to talk about. There's something called an AllJoyn router. We'll get into this in more details. So an AllJoyn router will go ahead and start moving messages. And applications that start to use AllJoyn, they can either contain the routing node or they can link up to another routing node. So this is just a fundamental concept, but what it allows for is kind of this mesh of stars. So any AllJoyn application can talk to any other AllJoyn application on the network. And when I say AllJoyn application, it's an application that makes use of the AllJoyn framework. The way that this works is that discovery and advertisement is ad hoc. One side exposes a set of capabilities that it supports. For example here, this device on the right side of my screen, this speaks media audio and media video. This application that maybe one of you developers writes is looking for audio or video, and in this case it's looking for audio. It'll find that on the network through a series of callbacks in the software that you would see, and then you can go ahead and form what we call a session. So a session is a means at which you connect either one-to-one or one-to-many for all the different devices that you wish to communicate with. And all this happens through the AllJoyn routers. The AllJoyn routers will form those connections. They'll maintain the reference counting, so if you have multiple connections to another device. And it also happens to handle all the low-level writes on all the different transports that are used. So the AllJoyn framework has the capability to support a mixed network, but right now the focus is on home solutions, home Wi-Fi, working in your home proximal space. And through the AllSeen Alliance, other members of the Alliance are bringing in discussions about how to bring in legacy transports and how to bring in the cloud infrastructure. So it's a very neat thing to watch this open source software grow. So what makes up the components? AllJoyn sits at about on a TCP stack, for those that are familiar, it sits about at a 3.5. really is where it is. So the software sits on top of all the OS communication APIs. It makes use of whatever platform it's on, whether it's Android, iOS, Windows desktop, Linux desktop, OS X, or even running on an MCU. It takes advantage of the low-level APIs that are there for the physical transports. Then it adds on the software on top for the router. And that router is just moving what we call an AllJoyn message across the network. That's its only functionality. It knows what core libraries, what applications that use those core libraries are connected to it, and it knows how to move messages up or over on a given transport to another device. The core libraries, that's what you would use as a developer in order to interact with all the different devices that can be discovered. You'll set up, on the high-level OSs, you'll set up your callbacks, you'll set up and create your objects that you're going to expose, and that's really the APIs that you're going to expose. And you'll start to form your connections in your application logic. We have an extra value-add piece of software that we call our AllJoyn service frameworks. Now these are almost like micro AllJoyn applications in a sense because they provide a very specific piece of functionality that we're going to get into later. But if you use one of these services, for example, notifications, then you'll be able to send notifications to TVs that support receiving AllJoyn notifications, or any other device that's capable of doing so and rendering a notification. So it's in essence building standards. Now each of these pieces here, for each of the modules that I talked about, the router, the core, and the service frameworks, these aren't just specs. They're software hosted by the Linux Foundation on the AllSeen Alliance that you can go to github.allseenalliance.org and pull down the software. So it's all there as part of the open source project, readily available for anyone to use. That core library there is split into two parts. One is our standard core library, sometimes called FL or SCL for short, and that is what runs on a high-level OS. It manages multiple threads. It has more complex API sets, mainly because of the multi-threading that exists in the framework. It also has another series of capabilities where it can bundle in that router with it. So you can have one application that you download from an app store on a mobile device, and that has all functionality self-included that can interact with any other AllJoyn entity in the network. Now for supporting the Internet of Things, you need to support tiny microcontrollers. And that's where we have the AllJoyn thin core library. Now this library is designed to run on very tiny microcontrollers. It has the exact same functionality that you find as far as the ability to expose itself as an AllJoyn application and interact with other AllJoyn applications as a standard core library, just on a very small footprint, and it's a single loop execution. So these main components here, regardless of which entity you use, the standard or the thin, you look like an AllJoyn application. So I could go build a device that's maybe a little push button sensor that's going to send out some AllJoyn notifications when the button's pushed. And one of you out there goes and writes a mobile application on Android or iOS or any other platform. You don't see that you receive an AllJoyn notification from a thin library device. You see it from an AllJoyn application. There's no difference at the software level for the interactions that you can have. So the thin core library, this is how you use it to publish the APIs across the network. And you can go and download the SDK from allseenalliance.org. There's a download tab at the top. So if you're doing any Android or iOS development, it's already pre-compiled. You don't have to build from source. I mentioned this before again, the standard library is really designed for high-level OSs. It's natively written in C++, and each of our language bindings, so for Android you can write up in Dalvik using the Java language binding that wraps up the JNI code. You can write down in the NDK. On iOS you could use Objective-C, or you could write in C++ and link that yourself. And even on desktop platforms, you could write in any of the other supported languages. The big thing, again, about the thin core library, the TL, is that it must have an AllJoyn router in the network to be able to offload processing power onto in order to communicate with the rest of the network. This is how we are able to fit AllJoyn the AllJoyn framework on a very small memory footprint. And it's natively written in C, so it's really easy to take and port over to a slew of different real-time operating systems. The router, like I said, its main support here, it can be bundled in or it can be a standalone service by itself running. So traditionally on, say, a Linux system or OpenWRT, you could have this running as a daemon process. And its functionality is to manage the bus and interact with other routing nodes in the network. To use AllJoyn, you don't have to understand this, but conceptually, it's nice to know how the flow of messages when you make a method call using the AllJoyn SDK, how that travels across the other side to the other device. So the message routing, it delivers the messages, it knows what's connected to itself. It really does the heavy lifting of the system. And all the applications depend on this being there to manage and interact with everything else. So the concepts that you'll be using as a developer is that your AllJoyn application and any AllJoyn application exposes APIs through what we call a bus object. It's a very object-oriented approach. It allows you to extend, you have a collection of interfaces. You could extend those interfaces. You can implement multiple interfaces on an object, and you can implement those same interfaces across different objects in your tree. And there's a whole object hierarchy that can exist. And the interfaces that you're going to create, which I'll describe in detail, will contain methods, signals, and properties. Methods are really RMI or RPC communication, so remote method invocation, remote procedure call, one-to-one interactions, calling a method and getting a reply. Signals are asynchronous broadcast. You can send them one-to-many or one-to-one. And then properties are basically built-in get and set methods on data members. And the powerful thing about properties is there's a get all properties. So you can get all the details in one method request. The other thing that's really important that's part of AllJoyn that's included in some of the service frameworks that we have, and one of the features that I'm going to talk about later that's one of the new 14.06 features, is the concept of introspection. This is the ability to ask a device at runtime what its capabilities are and be able to get back a list of the interfaces that it supports, and then you can create those objects in an object-oriented approach. You can create an object that came back and then start calling methods on it. So the advertising and discover piece, I talked about it briefly. How that works under the hood is through a feature that we call the about feature. There's a standardized interface that's org AllJoyn about, and it contains a set of a signal that goes out across the network, and that's the data that travels with that signal, the method arguments. Those describe the make, the model, the manufacturer, as well as a list of the interfaces that it supports. So it's really a shortcut. Instead of needing to directly ask the device and parse a tree of its capabilities, what is it that you want me to know that you support? For example, I can see something that supports control panel or media audio, as we talked about earlier. And so one of the changes in 14.06, the way that this about interface works is using something called a sessionless signal. I have slides on this that we'll go into. Conceptually, it's just a way to publish information without explicitly connecting to every application out there. There's an optimization, so if you look and you monitor these names going across these advertisements that are being sent out, you'll see it's now org AllJoyn about.sl for sessionless. So it's a slight optimization, and it helps optimize the network as we have more AllJoyn devices coming to market that are taking advantage of all of these different capabilities. Now, one of the neat new things that I want to touch on that we added for the AllJoyn 14.06 release is an ability to more accurately detect presence of an AllJoyn application. So what that means to you is in the previous model, prior to 14.06, if you had two applications on a mobile device and one mobile device walked outside of the proximal network, so maybe it walked away from Wi-Fi range, it would take 120 seconds at worst case in order to know that that device is gone. What we've allowed for now is we've moved to using unicast MDNS packets, and we've provided all of you out there with a new API call in our bus attachment class a ping method, where when you're not connected to another device, you can check it and ask it if it's still present in the network. This now allows you to set and control your detection of when an application you're interested leaves down to, say, 1 second, 10 seconds. You have the flexibility now to put that level of control in your hands. Sometimes people ask, well, what is this AllJoyn interface? And you've said it a few times, and how do I create it, and what's it comprised of? So you can really think about an AllJoyn interface as your header file to the distributed system. Like I said, it can be introspected, but this is where you define your methods with the arguments that you will accept and the arguments that you will return. It's how you define your signals. So what are you going to send out across the network when an application is connected to you, or what might you publish for anything to be able to understand? And what variables do you have that are accessible, that can both be set and queried? Are you a temperature sensor and you have temperature that you're publishing as a signal, or are you asking a developer to connect up and call get temperature? How are you defining this? And it's really, again, like I said, if you kind of consider each of these AllJoyn objects as a little tiny library that you're publishing across the network, and the interface is a header file, when you use the software and you start to write your application, it's going to make a lot of sense. So, data types. What can you send across the network? What can you send to other devices? How can you invoke a method with certain arguments? So we support multiple primitive types: strings, integers, unsigned integers, both 64-bit, 32, 16, shorts, bytes, floats, and a special string, which is an object path. So those are all the primitive types. You can send those across the network. You can also make an array, which is a collection of those types. And these letters here, these have a meaning when you define it in software and in the Introspection XML. This is how we have a shortcut for determining what the variable types are. And you'll see that in the next few slides. You can also have a structure, which is basically a record or a struct in its primitive sense, that is a collection of a certain number of values. So, for example, a contact could be represented as a name, an email, and a number, where it is a string, and an integer. Or that could have been a long, that would be an X, or maybe a number is a string in your concept. It's however you choose. We also have dictionaries. So this is key value pairs, where the key can be any of the primitive types, as is the value can be any combination of the primitive or complex types. So for example, maybe a player table for a game could have a hash where there is the player name, and there is an array of integers that represents its position in space. There's another thing too that we have that's a variant. Now, it's a very powerful piece. It's used by the About feature, and it really provides flexibility. You still need to know what it is you're pulling out, but it allows you to publish arbitrary data in a method and interpret that value at runtime. So maybe you have a method of update player, and it has a variant that it accepts as the argument. And at certain times in the game that you create, it could have a player name. Maybe it has a structure that represents its current health information of a player, or so forth. Or maybe this is a device that you're creating, and it's going to be an adapter to a TV. And you want to be able to send it maybe a mix of data for streaming. So maybe it's a video or audio or pictures. And so you want to stuff that into show content, and you pass it some sort of content variant that your application on that side will be able to interpret at runtime and take appropriate action. So the way that this works is there's a type ID field, and you can inspect that and then use the APIs to pull out the correct element. So that's one of the important things here with AllJoyn, is that it does the data marshaling for you. So whether you're writing a thin core library application or a standard core library application, say in iOS and Objective-C, and maybe another one up in Dalvik using the Java language binding. And each of those different applications, you can send a char star over to an NS string. It'll come out in the iOS application or the Objective-C application. Over in the Dalvik application, it'll come out as a string object. So AllJoyn is going to do that all for you under the hood. So the way that you define XML markup, and by the way, an interface can be interpreted and read as XML. It's just a way to help define it. It is not XML after this fact. It is just a software object, a data object that exists in memory. So there's different tags that are there. There's the interface name. There's the member name that makes up a bus method. There's a signal with a name that makes up a signal. And inside each of a bus method or a signal, you have these argument tags that define the variable name that you would like it kind of known as. And that could be anything. It's up to you to choose. It could have a type, and these are those S's for strings, those I's for integers, the X for long that we had up above, and whether it's an input or an output argument. And a property is simply just giving that same thing only in one line. You specify access as well, whether it's read, write, or read and write. Now, interfaces are contained and implemented by a bus object. So this is just a class in a hierarchy that is implementing these interfaces. And these have a name called node, or a node tag with a name that represents a path, like a file system path, on where this lives in the remote application conceptually. So if we look at an interface here, this is actually the about feature interface straight from the specification document. You can see it lives on /about. The interface is org AllJoyn about. There's a property, there's a method, and there's another method here for get object descriptions, and then there's a signal of announce. Now this signal right here is a signal that is it's a sessionless signal, and I'll explain that. Sorry for bringing up the term, but it will publish out, and anything that's interested in receiving this announcement will do so. And part of the specification for about will describe in the object description this array of records of an array of strings. It'll describe how this is supposed to be structured. This is where we have the object path to the array of interfaces, and the metadata, which represents the device, the make, the model, the manufacturer, maybe a serial number, a version. All of these different things can be stuffed in here to this array of key value pair variants, and the spec describes what those strings are so they can be interpreted. And they can be extended by anyone using this to add in device-specific features that they want to promote, maybe in some UI on their mobile application if they're creating, say, a set-top box or a TV or a microwave or a dishwasher, and they have certain values that they want to make sure show up in their application. They can stick them in here. So bus objects, I've said it a few times, this is really, it's the base class that allows you to expose whatever object you create with the interfaces. It makes up the set of APIs. The way that your object gets invoked on a remote application is via a proxy object, so a local representation of the remote entity. And that object, that proxy object, knows how to use the AllJoyn APIs and use that AllJoyn router to move the message across the network, execute that code on the other device, return the response back, and pass it up into your method right where you left off. So AllJoyn method calls are blocking. There are asynchronous method calls using the APIs that you can use in order to have a callback and not block in a UI, say on Android or so forth. Signals are also emitted from these bus objects, and they are consumed by a registered signal handler. So you need to, using the APIs, it's simple to do, and you'll see it when you start looking at the examples in the SDK, but you just register a signal handler. You say, when this signal from this object comes in, I want this method to be called. And it's a very nice, simple framework, and it works really well. And when you look at the sample code, you'll really start to see it. So this is kind of in a traditional sense. This could be a game right here. As you can see, I've talked through a couple game examples, but AllJoyn is more than just multiplayer gaming. That was the original focus, and it's evolved to powering the Internet of Things through the AllSeen Alliance. And so on this slide, you can see there's two applications. These are AllJoyn applications. The router is bundled inside of it. These could be on mobile devices. We have our bus attachment where we have registered our bus objects that implement these interfaces, and we're now able to have these player pieces exposed and interacted with in a very object-oriented approach. So the way that this works here, like I said, when you call a bus method, they're one-to-one, and it's blocking unless you explicitly call an asynchronous call. But it uses that proxy object. It's going to travel through the AllJoyn router. The AllJoyn router is going to know which transport and how to write on that transport to the endpoint that you're represented. And it will move that message over. That will then execute the code in the bus object, and it'll return the response. Or it will return an error if there was one. There's also a timeout in case the device walks out of the network proximity, so you'll have that awareness. Signals are very powerful as well. Like I said, they're asynchronous publications. There's no reply to them, so you have no acknowledgement that they were received by the other side. You have an indirect acknowledgement. If you're in a session, you'll know unless you receive a callback of a session lost, you'll know that they received the signal on the other side. And the important thing, too, is that signals are reliable. So when I send one, as long as I'm connected, it will go to the other devices. They can be one-to-many, so I can index all of the devices that I'm connected to, or I can index everything that's out there. And there is a time to live associated with them. So if for some reason one of the systems you're interacting with is has processing complexion problems and it's running very slow, they can drop signals on the floor and process them later. And they're also, unless you thread sending a signal, they're received in the order in which they were sent. So the way that this works is a bus object emits a signal. It travels through the AllJoyn Software Framework, through specifically the AllJoyn router, and passes it up into your signal handler and calls that method. Sessions are really conceptually grouping applications. You can group one-to-one, so app 1 and 2 here are connected in session A, and sessions are defined by a session ID, a numeric value. Session B here, or some numeric value, would say could have 2 and 3, or we could have a session with all the devices here that you see, all the different AllJoyn applications. And the way that this works is that now, with having these multiple session IDs, app 1 could interact with app 2 by sending a signal on its session A ID or session C ID, but when it sends it on session A, only 2 receives it. When it sends it on the larger session, then just as you would expect, 2, 3, and 4 would receive it. So it's just a way about conceptually grouping your interactions. The way this works here, looking at a flow with all the API calls, and I'll talk through it. One side advertises, again, using that about feature. I'm advertising org AllSeen training. That travels into a callback for the about handler. There's a join session that occurs, one of the API calls. There's a listener to accept session joiner, which would return true or false to allow the connection to process. That then kicks off simultaneously on both sides, a return response of status OK with the session ID, and also on the session joined callback. And then now we have a session ID here that's established. So once we have the session ID, we're physically connected using the AllJoyn SDK, and we can take advantage of interacting with the bus objects. Now conceptually, at the high level, one of these sides of the applications, app A in this instance, was the one that bound a session, and app B was the one that joined. That's just to form the link where one side is a client and server type of logic. Once you're connected, you are peers in the AllJoyn bus architecture. So a client could also expose bus objects much in the exact same way that the service exposes bus objects. So there's no notion of client-server in the traditional sense where one is always acting as the server pushing information and the client requesting information. You are both a client and server at the same time, and you can choose how you expose that functionality. So to complete the process, emitting a signal, it'll travel across and it will go to the registered signal handler there over in app B. Now I said sessionless signal because it's pretty powerful. it's going to simplify your life if you use this. Here's how a sessionless signal works. You register a signal handler on a device, and then a signal travels out. No longer are you needing to explicitly look for a set of capabilities, join up, form those connections, and wait that kind of connection time and setup and burden yourself with that extra application logic. What you'll do now is just set a flag when you send a signal from your bus object as AllJoyn flag sessionless. And when you do that, it will travel to any application that is registered to receive a signal handler on that interface name. So it's really powerful. It's exactly how the About feature is functioning in its low level. It's how the Notification Service Framework is able to send notifications that can be rendered on a TV, maybe played audibly through a speaker, rendered on a tablet, on a smartwatch, on anything. It avoids the complexity of, like I said, needing to join up and connect, and it's really designed for small amounts of information, small data. It's not intended to transmit, say, photos or video files or files of that nature. The reason is that each signal that you send out that's sessionless, there is an overhead associated to it. So that forming a session and connecting up and binding, that's now moved into the AllJoyn Software Framework itself. So you're creating a temporary connection and then tearing it down each time you receive a sessionless signal. So there's the overhead there, and in that time period, when you publish a new signal, you overwrite the previous one. So it may not have been picked up by the other side. So if you are trying to send an image using this, it's overhead, and you're not guaranteed that each of the packets of the signal that you're trying to send out are picked up when they should be. So I said notification, I said control panel. These are those base services. They're those small functional library blocks that we have that sit on top of the AllJoyn SDK itself to really enable it so all of you out there can build applications faster and have quicker time to market. There's a notification service, which I'll go into. There's onboarding, which is how you connect a new IoE device up to your network. There's control panel, which is a one-to-one interaction on being able to understand the capabilities that are exposed from a device and interact with them. Configuration and audio. And each of those things leverage the About feature for that discovery. So if you're interested in building a universal controller for the Internet of Things, you can just look for anything that speaks control panel, use that piece of software that we have, and you'll start to render, and your UI will change as you come in contact with new devices. So the notification service is designed to be a very simple interface for sending human-readable messages. It's not intended for M2M, and it's really kind of considered the text message to the Internet of Things, if you would. There are hooks in there where you can add a audio URL or a image URL or even a small image in there that would fit in a single AllJoyn packet. And it will work across multiple different transports. In this software framework, there is a concept of a producer, which is the side that sends, and a consumer, which is the side that receives. So conceptually there is that, and you could build an application that is both producer and consumer in itself. So an example here would be maybe a device manufacturer builds a refrigerator, and they decide when the refrigerator door opens, they want to send out an AllJoyn notification so that their customer can see either on their mobile device that they download or on a TV that's commercially available what the message is, and maybe it's that when the refrigerator door is left open, so it reminds them to go and close it so their food doesn't spoil. We can see that now. So some logic could be here, and this could be done using the thin core library, that TL library. So if the freezer door is open for more than 5 minutes, send the notification out. TV says the freezer door is open for 5 minutes. This would be whatever the device manufacturer would place in there for that message. Control panel's similar, except for it exposes the capabilities that can be interacted with, and there's a UI adaptive layer so that on Android it looks like Android widgets. This could be customized by any of you out there. You could go and download the software project from get.allseenalliance.org. You can make changes to the adaptive layer so it renders to your own custom look and feel. It also, on iOS, it would look just like iOS widgets. And what it allows for is two sides. There's a control-E side and a controller side. And it really is a generic way. It could be a smart plug that exposes on and off. Could be an oven, as you see here, that is set to turn on to bake at 250 degrees. The novel thing about Control Panel is that it can be added in to a notification to provide a notification with action. So that's another more complex use case that if you're ever at one of our, at the AT&T Hackathon and you see one of the members of the AllSeen Alliance, you'll be able to come and ask us if you're going to use this feature, and we can help you use it and use the APIs to really build out your vision. So an example here would be a refrigerator. What might I want to control the refrigerator? Well, the control panel, the application that is showing here on this tablet, it has no knowledge of what it is in advance. So it asks and it uses the low-level concept of AllJoyn, the introspection, and it pulls over its controls and values. And it sends those back, and then it sends over the different properties that we request. So I know that it's 13 degrees Celsius or Fahrenheit or whatever is there in those properties. And we can go ahead and turn that freezer up or down, and maybe we increase the temperature here a whole lot. And now we've changed the mode. Now, one of the powerful things, I did say Control Panel is a one-to-one interaction. It's interacting with an AllJoyn application on a device that's exposing its capabilities, but it's also synchronized for the widget sets. So as I would have changed that temperature up, if one of you had an application using Control Panel connected to the same appliance, you would see those changes happen on your device as well. So it's a pretty nice feature to see. By just including this Control Panel Service Framework SDK, you get kind of some synchronization between things, and it's really buttoned up, and hopefully it's going to enable all of you to be able to build a lot of powerful applications. So control panels, it may seem a little complex on how you create this. Right now we have the ability to use a tool to design using XML on how you want the widgets to be laid out, whether you want it to be a slider, a toggle button, a regular button, maybe it's a checkbox, so forth. You have that abilities. There's a code generator inside the project. You feed it an XML and you tell it which language binding or which standard core library you want to use, whether it's the, it'll come out as C++ for the standard core library or C for the thin core library. And what it gives you is a generated code folder, and you provide the provided code, which is the implementation of what happens when the temperature is increased or the temperature is decreased, or when the on button is pressed. Your code then executes for that, and now the entire system's linked up. So this is a big helper piece. There's documentation on how to get started that you can go and find on either wiki.allseenalliance.org or on allseenalliance.org under the developer guides section. So this leads me to one of the very powerful features of 1406 that has been present really for a while, but we've fully formalized it in a way that makes a lot of sense and is going to really enable a whole new set of use cases and a whole new way at which you're going to be able to write some applications. Call this events and actions. It's basically a way to understand in a human-readable way what a AllJoyn application can send and what it can do. And it's really about a way to take a signal, which is what we call an event, right? And we attach a human-readable description to it. So I can see that the refrigerator sends out, not door open, it sends out a string that I can then understand when it's fired, when the signal is sent out. I could see it in the UI, and it will say, the door is open. So I can read that, and that'll be the first part of a sentence. And then an action, that's just executing a bus method call. So you would add a description to a bus method, and it forms the end of the sentence. So maybe this is a light bulb. So I can now have two completely separate devices, a refrigerator from one manufacturer, light bulbs from another manufacturer. I can go and use an application now. That application discovers both those devices. It discovers the descriptions that are there that can be presented in a UI, and now I can give an ability to the person that downloads my application to link these things together, such that when the refrigerator door is open, the lights blink blue. So we can form a complete sentence. And that's the whole concept of events and actions. It's taking everything that was already there in AllJoyn, in the AllJoyn Software Framework, and making it easy for an end consumer that uses a mobile application or that wants to find out about information from the devices that they have in their home and be able to understand it without being a developer. So in order to make this happen, we created a new interface. It's our org AllSeen introspectable interface. And we took the base introspection XML that's returned, we added in a new description tag, and on those signal fields that I talked about earlier, we added a new attribute that allows you to specify if it is sessionless. So you know whether you have to be connected or not. So here's the introspectable interface. It has get description languages, so you can implement these descriptions in multiple languages and translate them on the fly. There's also the method in order to get that XML with those descriptions, introspect with descriptions. So it's a new interface, it's part of 14.06, and there's a sample that's there. With this comes some API changes to each of the different supported languages that I'll go through right now. In the standard core library in C++, there's a couple new calls, so when you create your interface, you can call set description language and tell it whether you want English, maybe French, Italian, German, Dutch, whatever you have you. You can set the description on an object. You can set a description on those members, so the method, which would make it an action, or a signal, which would make it an event. And then the arguments could even have descriptions. So you could have a signal that sends out the light color changes, and the argument could be an enumeration value, and the description would be 1 when red, 2 when blue, 3 when green, for example. So you can really have full control of however you want to design this, and it's very, very powerful. Using the Java language binding, it's a little bit easier to add this. You just go into your interface that you've already annotated and created. You'll see this in the samples. And you'll just add in description equals, and you put in the string that you want. And then if you wanted to support multiple languages, you could put in for that description an ID. Maybe for that MySignal, we call it MySignalID. And then we have a translate function that's going to take that tag, take the requested language, and provide a complete string back to the calling application. On the thin core library, it's implemented slightly different. Because of the nature of a thin core library application needs to be memory constrained, we're running on small microcontrollers, maybe with, 35, 50K RAM, and maybe 6K RAM and 35 to 50K flash. You want to really conserve space, so it's table driven. There's a way to index the description that's being requested, and that's through a macro AJ description ID. It's just an encoding, which will tell you what the object that's being requested is, the interface index, the member index, and the argument index. So you can go ahead and return back the appropriate description. And then there's a function pointer there that you implement, which is your translator, and you'll do that in your application outside of the AllJoyn Software Framework. So one of the things in the the AllJoyn Android SDK, there's a sample application that you can load. Unfortunately, the Java language binding does not allow for you to dynamically create interfaces. So this is a NDK application, an Android NDK application. And it's precompiled. You can just run it, so you can build out each of your sides, and it will show you the events in a list. It will show you the actions in a list, and it will allow you to link an event to an action. And it has a local rule engine that's there. And that rule engine software is written in C++, and it can run by itself, maybe on an OpenWRT instance, maybe your developer laptop. And it uses the AllJoyn framework with an example interface to connect up. Now, the important thing is that when it's a remote rule engine, it doesn't persist the rules, it just stores them in memory. But it does offer tracking of devices. So when a device leaves the network and comes back in, the rules will update so that they'll always be able to be accessed and valid. So it's a very nice piece of software. The big thing here with this is it's intended to be a sample, not a hardened solution. So you would have to take this or take some functionality of it and really put it into your application. Maybe you just expose the events and actions. Maybe you take this and you build a very robust UI around it, and you go through a bunch of tests to validate and ensure that there are no bugs or issues with it. But it's there as a sample, ready for you to use. It's part of the AllJoyn Core Git project that's up there on get.allseenalliance.org. The other thing is that it's really a showcase to show the power of events and actions. It does track it. If you, as we are as developers, you might want to understand a little bit of the low-level details. So when you use this application, you run it, you'll be able to long press on any of the actions or events that you see in the list, and it'll provide you with all of the information that makes up that action or event. So it gives you the object path, which device it lives on, what the interface is, what the member name is, that it is, what the actual function signature is, so the member name and the arguments. So it's pretty powerful. It also, in the Android application, it allows for you to save the rules locally, and you can delete all the rules, and it's pretty fun. Yeah, so at its high level, the application, for its application logic, it starts up, it looks for the about feature. Whenever it finds an entity, an AllJoyn application, it will use that introspection with description method, and it parses the XML, and it shows any of the descriptions. The rule engine, what this does is it registers a signal handler for the events, and it ties that to calling a bus method for the action. Now, it also tracks using the about feature, so that the unique name endpoints, like I said, when a device comes and goes, it'll auto-adjust to that network change. The benefits of using events and actions is that as a end consumer, you can link different products together quite easily. You get to build these sentences. The lights in my, when the motion sensor goes off, the lights outside blink. When the temperature outside drops, the heater turns on. So you can build these different sentences, and it's very neat. There's no impact to your product. All you do is just add these descriptions, and now you get the ability for someone to link them together. There is a slight impact where you have to ensure that the strings that you use are good strings to use. It removes the burden of needing to think of those use cases that differentiate your product. If you kind of look at the mobile evolution and what we all did as developers when we had access to the camera, to the flash, to all these different device capabilities, we were able to create new things, turning our phone into a flashlight, turning a phone into a pulse detector. All these different things, if you're building a product, a refrigerator, microwave, a dishwasher, a sensor that goes somewhere in the home, if you're building anything, even a mobile application, you can expose these events and actions and just let end consumers be creative and link things up as they can do and what they've done in the past historically. The drawbacks, I did say this, and these are kind of just things to consider really more than drawbacks, is that you must have a good description. To say door open, that's kind of a fragment sentence, right? A very small piece of a sentence should be the front door opens, where you try to get some specific details into it. You want to try to take some of the guesswork out and have some more specific signals. So if maybe you're a temperature sensor, you may not want to have the user have to think about parsing, setting up some input to type in some values. Okay, when the temperature is 90 degrees, maybe you just add a new signal that you send out, which is it's warm outside, and the description is it's over 90 degrees. Then you can have that whole behavior and link it up, and your end consumer has a simpler time setting up rules. So just trying to be a little bit more creative in the thoughts of what you're exposing. And again, to reiterate, the descriptions should contain a part of a sentence, so that when you take an event and you put it next to an action, it reads like a sentence. The front door opens and the lights turn on. So being able to form that together. One of the drawbacks, and it's a positive to the AllSeen Alliance, but some hardware manufacturers like to have their product interact with just their product in a vertical solution. Using events and actions, you break out of that vertical block and you interact with everything around you. So if your mindset is vertical solution, this is a drawback. In the nature of the Internet of Everything, it is a huge positive that can now exist and things will interoperate. This leads me to the last big topic that I want to discuss, and I know I'm getting a little short on time here. So we have a new concept, a new project, a Git project that was just added recently within the last month here, and it's AllJoyn.js. And what this combines is the AllJoyn Thin Core library with the duct tape open source JavaScript ECMA 5 script 5.0 compliant runtime engine. And then we've added in and inserted into the JavaScript engine the ability to interact with AllJoyn APIs and some different I/O peripherals. So on a Arduino Yun, for example, using this, there's a sketch that you can load on the Arduino side. You can compile this piece of software from the Get.AllSeen Alliance, load it on to the Lenino side of the stack on the Yun, and you'll be able to run JavaScript functions and interact with things. You can also emulate this on your Linux machine, your Windows, or your OS X desktop or laptop. There's a console service that will allow you to interact with things. So the architecture, slightly different than the other language bindings, because what we have here now is a board support package. So running on certain platforms, you want to have access to GPIOs. And by the way, on these desktop systems that I listed, we have a Python script that emulates GPIO instances. So you can have a checkbox to toggle a GPIO. You can change some values. So there's a GPIO emulator that exists. So it's pretty powerful. But what it does is it takes all of that piece there for the AllJoyn Core library, adds on the services, and does an implementation of those services to expose them through into that ECMAScript 5.0 engine. As such, you write a JavaScript application and you use a little bit higher level APIs. There's a console service that will allow you to program on the fly that JavaScript file that you run. It'll allow you to get debug information, so it's really powerful. With that console application, you're also able to do evaluations of variables. So you can eval 1 plus 1 and it'll return 2. You can eval a variable. Maybe you eval state. If you have a state variable in your application, it'll return you the current state. So you can really use it as debugging. When you push over a new JavaScript file, it'll overwrite the previous application. It also allows for real-time debugging. So an example here, this is just running the console. When it starts up, it's going to tell you it's AllJoyn endpoint ID. It's a unique name is what it's called. When it joins up to a AllJoyn.js application, you'll see a join session with an ID. So that whole process that we talked about earlier, it's all wrapped into these higher level pieces of software. And then if I wanted to print out the AllJoyn object, I do a JSON.stringify, just as you would to dump a JavaScript object. And it gives us here an eval. Here was the method that here's what you wanted to eval, and here is that object. So you can see this is actually a doorbell object. Its interface here is AllSeen doorbell, and instead of being interpreted as XML for its interfaces we were describing earlier, it's seen here as JSON. So I can see the object description, the interface on /doorbell. It has this interface. There is a method, a signal, 2 properties, so you can see all of this information that's there. If we wanted to look at our I/O object, I can see that there's all these different pins with different IDs that I can interact with, and it has a pull-up, pull-down, there's a rising edge that's set there, there's a falling edge on one of the pins. I can ask for a description of the pin, and it will tell me that this one is the red LED. We can ask for the functions that exists, and it will eval and tell us it accepts a digital out, so we can drive a red LED here. We could eval 2 plus 3, like I said, get 5, alert hello world, which sends a debug message out. There's the debug message there coming across of hello world. If we evaled hello world, it would also give us undefined. So The console's there. The whole programming model here is just as you would expect in a JavaScript engine. It's 100% event-driven, no blocking calls at all. Everything is asynchronous requests. So if you make a method call, you give it the reply function that you want to execute as your function enclosure. Everything there is registered through this AJ object that we've inserted here into the engine. So there's an onAttach callback, there's an onDetach, then there's method, when you receive AllJoyn messages like a signal or a call or a property request, you can take action accordingly. Then there's some other things that we have in there that really help around driving some GPIOs and everything. There's a set timeout, so you can have a function execute after a certain given interval. There's clearing the timeout value, setting that interval, resetting it, so all that's there. And then there's another thing too where you can set a trigger, so when there's a rising edge or a falling edge, you can automatically have the platform interact and call this method in order to interact with everything else. There's two built-in functions. There's print and alert. When these function differently when you're connected with the console. So it will print to local standard out when there's no console connected. When a console client is connected, like you saw me running a few slides back, that will be redirected to a console that it's connected to. So it gives you live debugging, or you can just run your JavaScript and see it print out and standard out. The interface and object definitions are slightly different in the different languages. It's very simple in JavaScript. We basically create our object here. We say it has a signal. It's a type signal with an argument of a string. Has a property that's of type property, right? And this is the name over here that we're associating with, and here's the description. We have a method that accepts an integer, two integers, and it returns a single integer. We can have another interface, and then we can add that interface onto an object path. Now, the AllJoyn.js side, when you do this, it will automatically advertise those capabilities across the network. So by just creating this object, it exposes it as a service for another application to connect to. So it's one way at which we streamline your development process. So base services, like I said, they're already pre-wrapped into this bit of software. Onboarding and configuration are completely transparent. Really, you'll interact with notifications and control panel. And I'll go ahead and show you those now. Notifications on the other platforms, you have to set up a few different objects in advance. In the AllJoyn.js, thank you, David. I'm sorry, I'm hitting the 4-hour mark, so if any of you need to leave, I'm sorry I ran a little long here. On the AllJoyn.js, if you want to send a notification, you simply take that AJ object, call notification, pass in an urgency, which is 0, 1, or 2, give it the string, and then you could actually do this in the same line, but you could call .send, or on a separate line, call send on it with the time to live. So when we get to using this software, you're going to find that you can, within a matter of less than a minute, once you've got your environment set up, start customizing sending notifications based on GPIO pushes that you set up with an Arduino Yun or some other MCU, or maybe it's your desktop platform and you're running that Python IO emulator. You can set this up and you can start broadcasting messages that display on other people's applications or on other TVs that are there in the proximal network. So it's really, really neat, and I hope that you guys are going to use this to build some fantastic applications. The time to live can be, it requires it to be at least 30 seconds, but no more than 12 hours. That's just the latency that's set up as we've defined the limitations there. You can customize this, so you can provide different languages. The notification service allows for that, so you can add an icon to it, for example, a path to an icon to call back and request, say for to request the details of the icon in a separate method call, or you can cancel the notification so you can stop it from sending across the network. Control panel service is really nice because it will allow you to potentially hook up a bunch of different LEDs or motors or actuators or any other different types of sensors to a board, and be able to not have to worry about writing a mobile application. You can simply expose a control panel that will have a reference application be able to render the UI and start interacting and calling those different buttons. So maybe you have a slider that I'm going to create here that's going to blink an LED at a certain interval. So I create my control panel object, I get my root container, I'm going to go ahead and now create my slider, and it's going to have a string next to it that says it's its flash rate, and it's going to go from 0 to 500, and I'm defining this to be 500 milliseconds. So the range here, never mind. The range here is what I set it to, and the 500 up above there is the default value that I want it to be set with. The range I'm going to say is going to go from 20 to 1,000 at 50 increment values, and the units is milliseconds, so it's going to show that in the control panel UI on the other side. I'm going to now link up my LED, so I've already connected my circuit to my Arduino Uno or other developer board. I'm going to set the pin 1 as out. I'm going to create a method here that's going to have an interval that's going to go ahead and toggling at this rate value. So at whatever the slider is going to be set to, it's going to toggle that LED on and off. Then I'm going to set it up on the value changed for that slider widget. I'm going to have it set the function of resetting that interval with the new value. So this is how the LED is going to change when I move that slider on the other side. And then when I connect up and this JavaScript application runs on the onAttach, it's going to load that control panel. Everything else is all handled by that AllJoyn.js framework. And so this application is fully functioning. It's one of the examples in the project, and you'll be able to interact with it from a remote application. And there's the control panel SDK for Android has a reference application that's there that's pre-built that you can use. And there also is other applications that developers have written that will show control panels. So it's very, very powerful. So this leads me to start wrapping things up here. So for more information, I said AllSeen a lot. I said AllJoyn Software Framework a lot. For more information, you can go to the allseenalliance.org website or the allseenalliance.org wiki page. On the wiki page, you'll be able to look at the various different trainings that have been given, look at the different working groups that are driving to publish new standards with AllJoyn. Lighting Service Framework is one of them that's coming up. There's a gateway service. So those base services that I talked about, there's a base service work group, and then there's work groups for all the different member companies of the Alliance that are starting to propose new things. There is also a forums, ask.allseenalliance.org. It's modeled like a traditional Ask community page. You can ask your question. There are experts that are there as part of the AllSeen Alliance community that have been responding to questions. There's a public mailing list if you want to get involved. You can go to list.allseenalliance.org, look at those. If you just browse the AllSeen Alliance website, you'll see some information there, and there's also a monthly newsletter. So next steps from here in preparing for the AT&T Hackathon. Go download the AllJoyn SDKs. Go to the allseenalliance.org, download it, start looking at them, make sure your environment's set up to load those sample applications that are present, start interacting with things. So your environment should all be set up. If you're going to build from source, go ahead and pull down the source code and look at the build instructions for your platform. We have on the wiki page, there's a Hackfest section. There's also a Hackfest project. So if you go and pull down this Extras Hackfest, there are sample applications specifically designed in the project to be modified and to help leverage and jumpstart your development. So there's even ones for control panel notifications that are written in C++ that run on the Arduino Uno. There's pieces for tying into a joystick shield using C++, or even using, if you go to the AllJoyn.js project, you can use the AllJoyn.js software on there. There's an LED display where you can drive and push characters onto a display, so you could turn a Uno into a scoreboard. So there's some neat stuff there. And then dive in and get ready to start hacking, because it's going to be a lot of fun. Like I said, if you have questions, go to the ask.allseenalliance.org, start asking in advance. If you're confused about anything I have here, I'll be online to answer some questions. If you want to build from source, again, wiki.allseenalliance.org. It's got great build instructions. We're also updating it as we get closer to the event. with more information on the different platforms and with more samples and just giving you all the information you need to have a very successful hack. So with that, I will open it up for some questions, and I would like to just pause briefly and thank each and every one of you for taking the time out of your day to attend this training session, this webinar, and listen to me speak about the AllJoyn Software Framework and really what the AllSeen Alliance is doing to drive a interoperable Internet of Things, Internet of Everything, right? It's actually more than just things, because if it was an Internet of Thing, it would just be one different device connecting in a vertical. Everything should be connected. So I'm going to come back over here and thank you, and come here, and I will come into the chat window and see if anybody has any questions here. So I see some questions here that I'll go through and discuss. So there is security that's built into the AllJoyn framework. So the question is, how does AllJoyn handle security and potential cyber attacks? So one thing is the AllJoyn Software Framework has an ability to mark an interface as a secure interface, which means that there will need to be a authentication to occur. Now there's 3 authentication modes. There's a PIN code, there's a username and password, so SRP login, and there's a certificate chain authentication. So using those, it will encrypt the data that goes across in those different the bus method calls or the signals, or even in the property requests and sets. One of the things, though, is that in its current state, AllJoyn is proximal and does not leave its proximal space. So in the home, for instance, there is it's not full security, but there is a pseudo level of security in that the home Wi-Fi network that's there, AllJoyn sits behind that. So the firewalls and all the rules and everything that's in place that's protecting your network from being accessed from the outside, AllJoyn's already on the inside, so you can interact in a local sense. There's no server involved. It's direct communication on that local network. So the other question is, there are other known IoT, IoE protocols out there. This question states there's MQTT, XMPP, DDS, AMQP. How does AllJoyn handle them? So right now, if you look at the members of the Alliance, you'll see that some of these different protocols are championed by some of the members that are there. AllJoyn really is about proximal communication. It's about publishing an easy interaction across the network. So with this, we think that some of these different pieces out there are completely valid and make sense in an Internet of Everything space. When you look at AllJoyn and interacting in the proximal space, it is the most flexible piece of software that I know of, and absolutely anything is possible. I personally have been involved with using the AllJoyn SDK for a little over 3.5 years now, and I have helped supported many developers in my customer engineering role, and also on the Ask site in various different questions. And it amazes me at how creative each and every one of you are, and the different ways at which you're using this software. And there are really no ends to the limitations. So there's one more question that's here that came in, which is, so how would we propose a handle of non-conforming protocols? Really, this is not something for me on engineering to really speak to. It's really a discussion that should be had by the members of the AllSeen Alliance as part of the technical steering committee, and discussing, and really as a alliance, all the member companies coming together and just discussing the technology and what should make sense and what shouldn't, and really having that open forum. It's one of the powers of an open source project, and one of the reasons why the Linux Foundation and the AllSeen Alliance is running the AllJoyn software. So if there's any more questions here, if you could chat them away, or go ahead and come offline here and dial in, and we'll get them answered. So there's another question here, which is, can I use the Can I use this to hack home appliances, light speakers, and a 430 horsepower rally fighter car live on a Hackfest floor? So at the upcoming AT&T Hackfest, you'll be able to use the AllJoyn Software Framework to interact with a various number of devices. The different members of the AllSeen Alliance are going to be present. They will be providing various different levels of support. Some will be providing some hardware, some will be providing different sets of APIs that link into the proximal space of AllJoyn. For example, OctaBlue has a Node.js plugin that will interact and send an AllJoyn notification. So there are various different devices that will be present, all sorts of different things that you will be able to use. You're more than welcome also for this hack to bring your own little Arduino setups or your own different side hardware projects, and that might be your hack, is to get that AllJoynified, if I may. Yeah, I believe Joe Speed here has said Raspberry Pi. Yes, so AllJoyn can be compiled on a Raspberry Pi. It runs, AllJoyn again runs on Linux, OS X, Windows, Android, iOS, and embedded systems. That platform is capable of compiling AllJoyn on it itself and taking advantage of various different APIs from the core software itself or any additional packages that any of the Alliance members have added on. So I again want to thank everyone for joining, and I'll stick around for a few more moments. If there's any questions, please chat them in. Well, thank you, Joe.
All right, so it doesn't look like any more questions are coming in.
All right, well, thank you, Glenn, and thank you for letting me present here today.
Yeah, thank you, Brian. It was interesting to see an overview of AllJoyn SDK and what's coming with the new features. Hopefully those of you going to the AT&T Hackathon and Super Mobility Week will now know what is contained with the AllJoyn framework and how you can use this during your development next weekend in Las Vegas. Just a reminder that this presentation and all of our Bootstrap Week presentations will be made available later this week on our YouTube channel at youtube.com/attdev and also on our AT&T Developer Portal blog at developer.att.com. So one last time, thank you everyone for participating. Brian, thank you for presenting in this Bootstrap Week event. And if this interested you, we have one more Bootstrap Week event tomorrow at 11 a.m. Pacific Daylight Time. You can find that at attdeveloper.webex.com. All right, so thank you everyone. I'll see you next time.